Hi folks, let's go over 4 of the most common problems with 2D adaptive. Here we've got an example of a 2D adaptive. It's a 1/4 inch end mill and it's correctly ramping into a 0.59 diameter pocket. Here we've got a diameter of 0.3149, so a 1/4 inch tool should have no problem getting in there. However, even though I've got that geometry selected, I've got this exclamation point with a flag that says empty toolpath. The most common problem that we see with 2D adaptive is the last tab linking under your ramp, the helical ramp diameter. So what is a helical ramp diameter? Let's hop back into the model. And I've created a sketch. And that sketch, shown as this construction circle, is a 0.2375 inch diameter circle. So if I hit C and I sketch on that a 0.25 inch tool, you can see that that tool, a 1/4 inch tool, rotating around a 0.2375 helical ramp diameter would violate our solid model. It's too big of a helical ramp diameter for that tool to fit inside that pocket. So what's the math to fix this? We've added this helical ramp diameter sheet to the NYC CNC Speeds and Feeds worksheet, link below the video to download. But if you punch in your hole diameter and your tool diameter, we see that the difference in that diameter is 0.065 or so, and the difference in the radius is half that. So we've created this formula in Excel that includes rounding it down to give you some cushion. So the max helical ramp diameter would be 0.06. Let's update our sketch and see if that looks right. 0.06. So if we take a look, that is going to work. The tool will now fit into the pocket. Second most common problem, same pocket. I've got a small helical ramp diameter. This should work. Why am I not getting a toolpath? Under the 4th tab, passes minimum cutting radius. That radius combined with the diameter of the tool isn't small enough to allow the toolpath to get in there and generate. Let's reduce that. Again, my methodology is reduce it to something incredibly small, confirm that that fixes the problem, then you can go back, minimum cutting radius, and change it into something more reasonable. Minimum cutting radius is a little bit harder to understand with a true circle. So a better example would be in a feature like this, where you've got a 0.236 diameter corner radius. If you want the tool to spend its time getting into that, you can do that. But if you want to just say rough it out and you want the tool to ignore that, that's where minimum cutting radius can actually save you time by roughing it out. And then you may come back with a roughing end mill or more dedicated finishing tool to go ahead and take the time to get into those corners. You can also see that in the pop-up here on the Fusion 360 minimum cutting radius tips and tricks window. Third example, same pocket. Why am I not getting a toolpath? The other culprit can be stock to leave. We've got a small minimum cutting radius. We've got a small helical ramp diameter, but we're leaving too much radial stock, which means when you take that whole diameter and you subtract the radial stock, it's too tight for that tool to fit into. So again, take this down to something small, confirm your toolpath works, and then you can adjust it back out. And finally, what's wrong here? We are getting a toolpath, but the toolpath is in the wrong location. The key is the heights. Edit, 3rd tab, heights. Because our bottom height is selected contours, we need to go look at the 2nd tab, geometry, and we can see in this case, we've selected the contour at the top. Traditionally, the way I recommend that we select contours is we'll delete that one and we'll pick the contour in the bottom. That alone would fix this problem, as you'll see. But 2 things. One, you don't always have that option. Sometimes you don't have the right geometry in the bottom and you want to pick it at the top. So let's show how we can fix that. In our heights tab, our top height right now is listed as stock top. You can see that's all the way up here, but we know we've probably already machined that down. So I can change my top height to model top. What's my bottom height? What's not going to be selected contours because that's effectively my top height. What I'll change it to, and there are a number of options, the best one here though will be selection. That's now going to let me pick a plane or a contour that I can use that drive the bottom height. I'll pick that contour or edge, it calls it here, click OK. We now have a toolpath that both starts in the right location, slightly above the top of our hole, and goes all the way to the bottom.